Ever wondered how fish breathe? How do they extract oxygen from water, which is so different from the air we breathe? Well, the process is as fascinating as it is vital. And today, we're diving deep into the amazing world of fish respiration. In the underwater world, fish are constantly breathing. But how they do it is a bit more complex than you might think. Fish respiration involves two key processes: external respiration, which is the mechanism by which fish take in oxygen and expel carbon dioxide, and internal respiration, the enzymatic reactions that happen inside their cells to produce energy. But today we're focusing on the first, external respiration. To begin, fish breathe through their gills, a specialized structure that plays an essential role in their survival. Fish gills consist of multiple gill arches, with most species possessing 4 on either side of their head. These arches are critical, providing both structural support and a pathway for water to pass through. Each gill arch has 2 rows of gill filaments, one anterior, one posterior, on which the fish's respiratory system depends. These filaments form what is known as a hollow branch, and they're responsible for the crucial exchange of gases: oxygen in, carbon dioxide out. But it's not just the gill filaments that make the process work. The gill rakers, spine-like structures found on each gill arch, act as filters, helping to capture any debris or food particles from the water as it flows over the gills. Now let's talk about how water flows through the gills. Fish have a clever system in place to keep the water flowing in one direction, ensuring a continuous supply of oxygen. The process is powered by a dual pumping mechanism, where 2 pumps, one in the mouth and one under the operculum, work together in tandem. When a fish opens its mouth, the volume of the oral cavity increases, lowering the pressure inside. This causes water to rush in. Meanwhile, the operculum, a flap of skin covering the gills, moves to increase the volume of the opercular cavity. This dual action creates a pressure difference that forces water over the gills, allowing the oxygen to diffuse into the blood while carbon dioxide is expelled. But not all fish breathe the same way. Some fish, like sharks and tuna, use a technique called ram ventilation. Instead of pumping water through their gills, they keep their mouths slightly open as they swim. Water flows over their gills as they move, allowing for efficient breathing at high speeds. This technique is particularly useful for species with high energy demands, like the fast-swimming tuna. As the fish swims, water moves across the gills, continuously providing oxygen with little energy expenditure. Interestingly, when these fish swim at slower speeds, they may switch back to traditional pumping. But at higher speeds, ram ventilation becomes the main mode of respiration. Now let's take a look at the fine structure of fish gills. The gills are lined with tiny layers called lamellae, which vastly increase the surface area for oxygen exchange. These lamellae are supported by the gill filaments, and they play a huge role in making sure oxygen can be absorbed efficiently. What's even more fascinating is that oxygen doesn't just move passively into the blood. Fish have a countercurrent flow system where the blood in the gills flows in the opposite direction of the incoming water. This setup maximizes oxygen transfer, as the blood constantly encounters water with higher oxygen content, allowing up to 90% of the oxygen in the water to be absorbed. Once oxygen is absorbed in the gills, it needs to be transported to the rest of the fish's body. This is where hemoglobin comes in. Just like humans, fish use hemoglobin in their red blood cells to carry oxygen throughout their bodies. This allows fish to efficiently deliver oxygen to tissues that need it the most, such as muscles, which is especially important during intense physical activity. Interestingly, fish can adjust how efficiently they transport oxygen depending on environmental factors, like water temperature and oxygen availability. For example, in colder, oxygen-rich water, fish can carry more oxygen, whereas in warmer waters with lower oxygen levels, fish adjust their hemoglobin's affinity for oxygen to optimize uptake. So, the next time you see a fish gliding through the water, remember, its respiration system is a marvel of nature. Through their gills, specialized pumping mechanisms, and unique adaptations like ram ventilation, fish have evolved an incredibly efficient way to meet their oxygen demands. This complex process ensures that fish can thrive in diverse environments, from the deep ocean to shallow rivers, adapting to varying oxygen levels and energy needs. Fish biology is truly fascinating, and their respiration system is just one of the many ways nature's ingenuity shines through. Keep exploring with us as we continue to dive deeper into the wonders of the aquatic world.